In this video, I'm going to show you how to use some of the 3D toolpath commands in MasterCAM. To start, I'm going to create a 3D model. I'm going to start with a rectangle, a 4 by 3 rectangle, and then I'm going to extrude it. Select this rectangle, checked, make it 2-inch. Now I have this block. So what I'm going to do now is to apply a chamfer on this side, checked, 1-inch chamfer, checked, and then a fillet on the other side. Click on this edge, checked, 1-inch fillets. So I'm going to machine this surface and this surface. Now before I do that, I want to tell you that it's important to understand how to use T-plane when you do 3D modeling, 3D machining. So let me show you an example. Right now, the WCS for this T-plane is right here. This means the Z-axis is on this direction. So your tool coming down in this direction, it will come down. It can come down to this surface. It can come down to that surface. But if the tool is not in that direction, let's say I'm on the right, the WCS looks different. The WCS now is this direction. So the Z-axis is travel along this axis. So it will cut this surface if the machine coming down, but it will not cut this surface, because if it cuts this surface, you have to cut through these parts to cut that surface. So it's important to understand how T-plane works. So right now we're going to set everything back to top, equal. So that would be my tool plane, and I'm going to machine this surface and that surface. Now in MasterCAM there are two groups of 3D toolpath machine command. So one is roughing, the other one is finishing. I had a separate video explained why we have to use roughing and why we have to use finishing. Now in here I will have to use the roughing to remove this material in order to cut to this chamfer, and similarly I have to do the roughing first to remove the corner material before I can apply the finish command. So now let's do the roughing. In roughing, I'm going to show you parallel and area roughing. In finish, I'm going to show you waterline, raster, and flow line. A lot of them, you can use any one of them. Just the end result, one might be better than the other, depending on the condition you are. For now, I'm going to use parallel for this case, and then area roughing for the other. So parallel, it is not a boss or cavity. I'm just machining that surface. I'm going to leave it undefined. This window, it shows you how to click, and how you click it, then how you select your surface, solid or feature. So in this case, I just want to have the surface. I'm going to click on this surface and selection. So this is one. That means I selected one surface. Checked. Now by default, the machine will give you a ball and mill. 3D machining, you will need to use a lot of ball and mills. In this case, I'm going to keep it the same, 1/2-inch ball and mill, but I want to show it on this here. I want to show it in here. So let me go to the ball and mill, 1/2-inch ball and mill. Okay, so it shows on tool number 1. And then surface, in here, they start to leave, because on the check I want to leave it 50,000. So I will have some material when I apply finish toolpath. And I'm going to keep this the same. Maximum step down. So roughing is going to rough layer by layer. Each layer is 10,000. And then when the cutting tool moves from one location to the other, it will move every 0.4 inch. So okay, and you can see this distance is 0.1 inch. So it would move, cut this layer at every 0.1 inch, and then from this side to the next side. So every movement is 0.4 inch. So this move over is 0.4 inch. Now let me show you the difference between ball and mill and flat end mill. So I'm going to show you the black plots. Okay, so now you can see it here. That's 0.05 thousandths, so 50,000. So you can go back and using finish cutting to finish this surface. But I'm going to take a snapshot of that. You can come back and see the difference. And then I'm going to change this to flat anvil. Half an inch flat anvil. Regen. And black plot. You can see that also a 50,000 gap in here, but when you look at it, when you compare them, the center line is different. This is much closer to the surface because the profile of this cutting tool, that is a lot further away because this sharp corner is in here. So when do we use flat anvil? When do we use ball anvil? For roughing, it really depending on the material. It's better to use a flat anvil to rough because it is stronger. Right now, the way this will move, you can see this actually move up and down, travel along this ram. This means that I can have the entire length of this the cutter on the side to machine the surface. If this is a ball anvil, this area will be the one that's cut. Ball anvil, this area is not very strong. It's not meant for heavy cutting. So you will put too much load if you do that on the ball anvil. It's easier to do it on the flat anvil because flat anvil can take a lot more load. In addition, you can see this ram. The flat anvil travel this direction, so it will clean up the steps for you. But if this toolpath is not going this direction, it's going along this direction, then you will create a lot of steps. These steps look something like this. And then once you have a lot of steps, it really affects how you machine the finished toolpath. So it might put too much load on the ball anvil, and then you will affect the surface quality. So if you're using flat anvil, you have to be very careful how you use it or how fine this steps is. Now let's take a look at the other toolpath, and I'm going to apply it on here. This time I'm going to use area roughing. There's a different window. It allows me to assign how much I want to leave on the stock. So 50,000 I want to leave. And then I want to select this so that I can select this area, this surface, and selection. I'm going to keep the ball anvil. I'm going to keep everything the same. Now, instead of step down 0.1 inch, this by default is 50,000. I'm going to keep that. And OK. So you can see they are 50,000 step down, and you can machine all these small area. Now the big difference between that is this one actually come from outside, machine it in. This is actually from inside. If you can see the black plots. So you can machine it in and out. Typically, when you machine material, you want to start from outside, machine in. So these methods and both methods can do the same job. It's just that one can do much better than the others. And I just want to show you the difference between these two. So ideally, you should do parallel on this side. But if you use area roughing, it's not the end of the world. You're just not going to get a ideal cut in here. And then you're going to use a finish to finish the cutting. If this is a roughing, you can do it much faster using parallel. You can do much bigger steps, much bigger move across. Let me show you the difference. You can make step over a much bigger step down if this is a the right toolpath. If this is a wrong one, you will have to use a much smaller, so to make sure the tool won't break. And then you get the quality of the surface. Right now I have machined these two. Now I can apply finish toolpath. I'm going to start with the flow line, and I'm going to start with this surface and selection. In here, this flow line will show you the cut directions. You can see these lines. I can change it. So now it's in this direction. So for now, I'm going to keep it this directions. Checked. And this already select. Checked. I'm going to keep ball ML. In here, I want to make sure this is 0 because it's a finished toolpath. And I'm going to keep this the same. Now, scallop heights. The smaller this number, the finer the surface is. And if you want it to cross, it's much faster. If you want it very small, like this, it will need maybe 3 or 4 times longer machine time. So I'm going to show you 2. And let me hide these 2 surfaces first, these 2 toolpaths first. So you can see this setting. Right now, the cutting tool, let me take a snapshot again. And I'm going to change this setting to make it much finer. You can see this is much finer. It will take much longer, but it will be finer surface. So that is how we apply flow line. Of course, the real way, because right now this is not ideal. You don't want to start from the edge. You really want to start from the outside. There are many ways to fix it. What you can do is to draw this surface much bigger. And one way is to extend this surface by creating a new surface. So I can create this surface and selection, and I can actually extend the surface. Let me create that surface first. Create this and selection. Yes, I want to keep this. So I created this surface, and then I can extend it this direction of 0.2 inch, 0.25 inch. So there are many ways to extend it. So this way, if I redo this surface instead of on the black on the solid model, I can do that on the surface itself and selection. So now the toolpath extended. So you can do that different way. So let me go to show you another method, which is, I'm going to hide this. In fact, let me delete this surface. Okay, and then I'll reapply that surface on here. Regent. So this, let me create another one. I'm going to hide this first. I'm going to create waterline. So waterline works almost the same. Right now, because it's a finish, I want to keep this 0. And I'm going to use the ball ML. I'm going to leave these the same. All the same. Regent. Most likely because my surface is not selected, so I didn't select the surface. I have to select the surface. Checked. Regent. Now I can machine the surface. Now if you use waterline, if you actually look at this surface, you go around the whole entire surface. To stop that, there are a couple ways to do it. One way is to use this solid edge boundary. If I use that, it will not go past this line, this line, this line, that line. If I do that, it will stop before. It's not going to pass this line, it's not going to pass below. Same thing to the side. So you can do that, or you can add, and this option you can actually add some dimension in here. You can add 0.1 in here. This means that it will extend the line for you. So it will cut from the outside and in. So this option allows you to do that. Now, if you want to go a little bit more, a lot of time you want to go a little bit more, make sure that surface can be cut. If you do that, you cannot use this option. You cannot use the include silhouette boundary. So you have to remove this. But if I remove this, it will go back to the same problem I had. It will go around the parts. So one way to fix it is in your geometry to avoid certain surfaces. So I can select this. I want to avoid this. I want to avoid the top, and I also want to avoid the side. So end selection, checked, regen. So now it will go down a little bit to make sure I cut that surface. So I can use flow line, I can use water line, depending on the setting, how you do it. The flow line, if I go back on the geometry, I can change the directions. If I change this direction, I want to show it to you in here. So it will be up and down instead of left and right. So it will go up and down. Now let me show you another one in here. The other one is raster. Again, this is a finish, so I want to make it 0. And I want to select this surface. And selection, I'm going to keep it above ml. All the parameters the same. Again, the smaller this is, scallops, the smaller it is, the more toolpath you're going to get, the finer you're going to get. But the crosser it is, the faster you're going to finish your parts. But then it's very coarse. So I'm going to keep these parameters the same. You can see it machined the surface, but it will actually cut into the parts. There are a couple ways to fix it. One way, again, is to include this. But if you do that, you chop the toolpath. Anything outside is gone. Anything along this edge up is gone. So it will only cut certain area. To get around it, you do not have to use this. Instead, you click on the avoid surfaces. So you want to avoid this surface, that surface, that surface. You can actually avoid the top as well. Okay, regen. So you can cut this surface. So you can use different combination of it. For finish, for roughing, you just have to pick the one that be suitable for it. But majority of them, they are very similar. One will do better job than the other.